Hello friends, welcome to my channel. From today we're going to start our lecture series on fluid mechanics, which is basically for engineering courses, mostly civil and mechanical engineering. Right, so this is a standard syllabus of a university in Nepal, and we're going to cover up this topics in this lecture series. So first we're going to start off with introduction about fluid as matter as solid, liquid, gas, application of fluid mechanics in civil engineering, concept of continuum and control volume. In second chapter we're going to study about the physical properties of fluid: density, specific weight, specific volume, specific gravity, compressibility, surface tension, capillarity, vapor pressure, cavitation, viscosity, and Newton's law of viscosity, classification of fluid. On our third chapter we're going to study fluid statics. There we're going to study the intensity of pressure and pressure force, pressure and depth relationship, Pascal's law, absolute gauge, atmospheric and vacuum pressure, measurement of pressure using barometer, manometer and Bourdon gauge, pressure on plane submerged surfaces, pressure diagrams and center of pressure concept, pressure on a curved surface, forces on gates, plane and curved gates, dams and other water retaining structures, buoyancy and flotation, metacentric height and its determination, conditions of equilibrium, stability of submerged and floating bodies, fluid within a rigid body subjected to motion, acceleration and rotation. In our third chapter we're going to study kinematics of flow, that is Lagrangian and Eulerian approaches of describing fluid flow, types of flow as steady and unsteady, uniform and non-uniform, and laminar and turbulent flow. 1, 2 and 3 dimensional flow, discharge and mean velocity of flow, streamlines, streak lines, path lines and stream tube, principle of conservation of mass, derivation of equation of continuity in Cartesian coordinates and cylindrical polar coordinates, continuity equation for 2-dimensional and 1-dimensional flow, velocity and acceleration of fluid particle, local and convective acceleration, various forces act. In our fifth chapter we're going to study dynamics of flow. So here we're going to study about various forces acting on fluid, Euler's equation of motion and its applicability. Number 3, integration of Euler's equation of motion in one dimension to get Bernoulli's equation. 4, energy of steady fluid flow. 5th, Bernoulli's equation for real fluid. 6th, application of Bernoulli's equation to orifice and mouthpiece. 7, determination of hydraulic coefficients. 8, varying head flow and emptying and filling of tanks. Venturi meter, orifice meter, nozzle meter and pitot tube. Number 10, derivation of momentum equation. Number 11, application of momentum equation to calculate forces on pipe bends and reducers. Number 12, forces exerted by jets on moving and stationary vanes of different shapes. Number 13, concept of angular momentum. And number 14, problems of sprinklers. And our last chapter is going to be about boundary layer theory. Here we're going to study concept of boundary layer and its application, boundary layer concept along a thin layer, laminar zone, turbulent zone, transition zone, as well as laminar sublayer. And third, we're going to study boundary layer thickness, momentum thickness and displacement thickness. And number 4, smooth and rough boundary examples. So prepare yourself. This is mostly useful for the students of Purvanchal University, because this is the course of Purvanchal University. I hope I can teach you as much as I can, and I hope you can learn as much as you can. Thank you very much. We'll join in our next video. Please subscribe to my channel for more updates on my more recent lectures and all my consultancy services. Please comment on the video below and I'll get to you as soon as possible. Thank you.